Alright, I'm going to graph these two quadratic functions. I'm going to skip some of the work here, or I'm going to go quickly. So you might want to pause it. If you're still not feeling too comfortable with it, see if you can pause it and try to graph both of these equations. Alright, so if you pause it now, because I'm going to start rolling right away. So the vertex is at negative b over 2a. So that's negative 2 over 2 times 1, so it's at negative 1. So x and y. So I'm going to put negative 1. I'm going to go right here. And you're going to see what I'm doing here in a second. So negative 1, if I plug in negative 1, I get 1 plus minus 2 plus 1, and so it's 0. So there's the vertex, is at negative 1 comma 0 right here. Alright, and so since we have this line of symmetry right here, in fact I should draw it in, I only really have to do one side. Oops, that is not the straight line tool. I want this guy. Okay, so I only really have to do one side. Okay, so I plug in the 0, and the 0 is always very easy to do because it's just, that's the y-intercept. So you're just going to get 1. You're going to get 0 squared plus 2 times 0 plus 1. So 0, 0, and 1 make 1. And then when you plug in 1, so hold on, 0, 1, so that's this point right here. So if you have, and you don't have to draw the axis of symmetry, but if you have it in your head, or if you draw it for that matter, you know that the symmetric point should always be on there. So I've been doing 5 points in here, or in class I should say. You don't really have to if you understand what's going on. Once you know, oops, I deleted the wrong thing. Once you know what's going on here, you only have to do one side. The vertex and a couple of points, and then the mirror images should also be on there. So 1 squared plus 2 times 1 plus 1, so it's 1 plus 2 plus 1 is the 4, maybe. Alright, frustrating. 1 plus 2 plus 1 is 4. So I'm just going to write the 4 because that's crazy. So 1, 4. And then the mirror image point is over here. So we have our parabola. Alright. So boom, there we go. I figured I'd cheat and just do it during a pause. So x and y. Same deal. So A is, it's C. So not B, but C. So B is 0. A is negative 2, B is 0. There's no x term. C is 8. So the vertex is going to be at 0. And so I'm just going to pick 1 and 2, because those are easy to plug in. So the vertex is 0. I go negative 2 times 0 squared plus 8. Oh, that's 8. So 1, 2, 3, 4, 5, 6. Oh, it's a little chart off the charts. So there's 8. So 0, 8. Okay, I plug in 1. Negative 2 times 1 squared is negative 2 plus 8 is 6. So 1, 6. And then you have the mirror image point. I didn't draw the axis of symmetry, partially because it's already there. It's the y-axis. For this one, the y-axis is the axis of symmetry. Okay, because the vertex is on the y-axis. And then we plug in 2, we get 2. Negative 2 times 4, so works out to be 0 actually. So you get 0 here if you plug in the numbers into the formula. Okay? And so once again I'll pause and cheat and sketch the quadratic. Alright, so there we go. There's our quadratic. Notice I plotted these 2 points incorrectly, kind of wrong. It's supposed to go up 6, I only went up 5, so whoops, I caught it. But there you go. So there it is. So what? This is what we've been doing all week. Well, solving quadratic equations by graphing. These are 2 quadratic functions. Sometimes I call them quadratic equations, but it's probably better to call them functions because that's what they are. I mean, they're equations as well, y equals blah, blah, blah. But here's a quadratic equation, or excuse me, 2 of them down here. Okay? Notice the similarity here between what's going on here. F of x, blah, 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 blah. 0 equals the same blah, 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 blah. All right, f of x equals that, 0 equals that. So these are quadratic equations. As our experts at solving linear equations, at the very end of Algebra 1, you learn how to solve quadratic equations. One way of doing them is solving by graphing. It turns out, what's going on here? Instead of f of x, it's 0. Instead of f of x, it's 0. F of x is y. When is y 0? Y is 0 on the x-intercepts. So y is 0 on the x-intercept. So that's right. Let me do the disappearing ink because I don't really want it to stay. So it's 0 there and there. That's when y is 0. F of x is y. It's 0, well in this case, just this one spot. So guess what? The x-intercepts tell you where the answer is to this equation, where the answers are to this equation. We've solved by graphing before when we solve systems of linear equations. It's a similar idea. You can look on the graph and tell me what, or you can look and figure out what the answer to the equation is. So it's a melding of geometry, because we're looking at pictures, so it's kind of like geometry, and algebra. You're solving an equation by looking at a picture. All right, we did that in chapter 3, and we're doing it here. So what's up is that the solution here to this right here is x equals -1. Okay, I lost the pen. So x equals -1 is the solution to this. You just look at the picture. Okay, that is when y is 0. It must be right there. Plug it in to check. X 0 equals, well heck, we've already done it. We already did that. We know that when you plug 0 in to the function, which is off screen now, 0 into this function, the answer is, excuse me, I'm using the wrong one. What am I doing? I'm flipping x and y. We know that when we plug in -1, I'm sorry, I just transposed x and y, my fault. When we plug in -1, we crunch the numbers and we get 0. All right, when we plug in -1 into that expression, -1, -1, -1, we get 0. So -1 squared is 1 plus 2 times -1, that's a -2, holy smokes, plus 1, it checks out. Okay? Didn't really need to do that, hopefully. All right? Same goes here, except there's not one solution, there's 2. We actually already checked one of them. One of them is, or I mean, we should already know one of them is truly a solution. Sorry, that spazzing out there. When we plugged in 2, we got 0 for the answer. So we already know, for the same reason that we already knew -1 was a solution. These are supposed to be green, but too late. X equals 2, and x equals -2. So plus and -2 are the solutions. Okay? +2, -2. We already, like I said, we already have the +2, so I'll actually carefully, let me change colors. This is supposed to be green. 0 equals, and so a lot of times I'll put a question mark here when I'm checking. So 0 equals, does it equal -2 times -2 squared plus 8, okay? So, question mark. So this is +4 times -2. It's -2 times +4 is -8 plus 8. Sure does, checks out. So that is how you solve a quadratic equation with graphing. All right, there's 2 examples. So I'm going to go to the next page, which is just the steps. So what you should do is pause this and write it down. Okay? So there you go. These are the 3 steps. Make sure it looks like the ones we just had. Grab those suckers, write down what the x-intercepts are. Maybe if it's between 2 integers, what you'll be asked to do in the exercises is to say what 2 integers it lies between. So there is the limitation to solving by graphing, is that if it's a weird answer, and when I say weird, it's not really weird, it's just not an integer. If it's not something that shows up when you're graphing, then you just got to estimate. You got a ballpark estimation of, estimation of what the answer is, or answers. So boom. So here we go. We'll just do a few of these, and this is it. All right, this is all we'll do on the video here, and then we'll hit the ground running tomorrow in class. But all right, so how many? Oh, you know what? I skipped a little bit. Vocabulary that is spazzing out. Basically, these four things are all mean the same thing. Okay, these are all the x-coordinates of the x-intercept or x-intercepts. There's basically three different ways well, four, because this wasn't green down to the bottom is one way. But the x-coordinate of the x-intercept is the solution to the equation. Sometimes we call it the zero of the function. Sometimes we call it the real root of the function, the root of the function. All right, zero, root, solution, x-intercept. The x-coordinate x-intercept, often those are all used interchangeably. So these are terms you need to be familiar with. You've seen them before, I'm pretty sure. You saw them in Algebra 1, I think, at least a little bit. If not, don't sweat it. We'll talk about it tomorrow. So what? How many real roots, zero solutions? So how many do you see? So on the first one for this right here, if we were to solve, in fact, I should probably write it in, at least on the first one. If we were to solve this equation, 0 equals this action here plus 2x plus 3. The solutions to those are these x-intercepts. Okay, so there's two solutions. There's two x-intercepts. Okay, so that's how many real roots there are, how many zeros there are of the function, how many solutions there are to the equation, and it's at x equals 1 and x equals -3. Okay? Here, where is it? If I was to solve 0, I'm going to be lazy, I'm not going to write it, equals blah blah blah. Or over here, if I was going to solve 0 equals blah blah blah, the solutions to this, well, whoops, I just kind of misspoke. It's not solutions, it's solution. The solution to this quadratic equation is, what were we at here? 1, 2, 3. It's also a -3, actually. That is one of the solutions. You can verify. In fact, I would recommend being able to do that strongly, actually. You need to be able to plug in numbers into quadratics, and this is a good way to check. If you plug in -3, you should verify that, yep, you get 0. How many x-intercepts does the third one have? Wait a second, none. So guess what? This right here has no real solutions. It might have solutions. Okay, it does have solutions. However, they are not real numbers, and we will talk a lot more about that later, and you're going to hate it. But I shouldn't say that. You guys are honor students. You will love it. You guys like math. Okay? But there are no real solutions because there are no x-intercepts. Okay? It does not cross the x-axis. That'll do. We're already really long, 13.5 minutes. That's a long video. We will talk more about this tomorrow. There you go. Please I hope you took notes on this. I will probably check to see if you watched it.